Welcome to the first video. This is Math 030, 1.3. So our first objective is to solve quadratic equations using the square root property. First of all though, what is a quadratic equation? You probably already know, but I will just go through. A quadratic equation is one that has a square root in it. The technical definition is anything that is of the form ax squared plus bx plus c, where a, b, and c, those are just the coefficients, and a definitely can't be 0 because then, well, we wouldn't have an x squared. Anyway, that's all quadratic is. That's all that means. Now, in order to solve a quadratic, there's a lot of different ways we can do that. Essentially, we're setting it to 0 to solve. But the square root property is a very specific way to solve it, and the square root property can only work when b is 0. So the square root property can only work when we have one that looks just like this, where b is 0. So it's technically an easier way to solve. Basically, we're gonna get the x squared by itself and then just take a square root in order to solve for x. Let's do some examples. Okay, we have two very simple examples here. In Alex, it'll probably say solve using the square root property. Whatever, we just need to solve. Now, a quadratic, this is a very simple quadratic. There's an x squared. And we can also note that this is the same as saying this, if we just subtract 25 on both sides. So it is of the form ax squared plus c equals 0. But it's easiest to solve using the square root property if we don't worry about what's in pink. If we just solve, we make sure that x squared's by itself. It is. We take the square root. And when we take the square root, we're essentially asking ourselves, hey, what did we square to get 25, right? How did we get what was originally in white? Well, there's two answers. We could have squared the number 5, but we could have also squared -5 since they'll both give us 25. So there are two answers here, and you can also write it with a plus or minus out in front. Now down below in the second example, it looks like the answer should be 10 and -10, but it's not, because there is no real number that we could square to give us -100. That's the issue. So when we take the square root of both sides, we do get a here, but we cannot take the square root of a negative number in the real number system, so we do not have a solution. All right, these look very similar to the first two examples. However, the number that we are equal to here, neither one is a perfect square like 25 was. So we're not going to get integer solutions. Instead, when we take the square root of both sides, because that's how we solve, we're going to get, again, plus or minus. That's important. And then if we want to write an exact answer, we literally just leave it as root 35. That's because the square root of 35 is, well, it's almost 6, right? So it's like 5.9 ... It is irrational. It goes on forever. So if you need to give an exact answer, this is how you give it. No decimals. Exact means no decimals. So your calculator will give you decimals. If you are fancy enough to figure out how to keep it in this form, it can also do that for you. Look online. All right, number 4, 50 is not a perfect square either, but it can be broken down unlike 35. So we'll get r. And then the square root of 50 can actually be broken down because 50 can be divided by a number that is a perfect square. So let's think. The perfect square that fits into 50 is 25. So we can break down the square root of 50 into the square root of 25 times the square root of 2. Square roots work like they work with multiplication. So 25 times 2 is 50. You can put a root around all three of them. It's all good. Now we can break that down. And why do we do that? Because we want to pull as much rational as we can out of this number. The square root of 25 is the integer 5, root 2. And then I forgot my little plus or minus here, because we do have two solutions in the end. Okay, our last two examples here are a little more complex looking, but they're really not all that different. We do have parentheses here, so please do not add 3 to both sides. That is mathematically illegal. We have to respect the parentheses. It's entirely being squared, so we can go ahead and take the square root of both sides, just like it is. The square and the square root cancel out for better words there, just like we've been doing, and we are left with just a plain old x minus 3. On the right-hand side, I picked a perfect square, so we will write plus or minus 6. Now, we can't write our final answer this way. Remember our goal, we want x equals, and we don't have that. We're actually going to have two solutions here, and they're not just going to be opposites of each other. I like to draw arrows to just show our two trains of thought here. So we actually are going to split up this plus or minus. We'll have x minus 3 as positive 6, and we'll have x minus 3 as negative 6. And when we add 3 to both sides to solve, one solution's 9. Now be careful, don't just automatically assume the other solution is negative 9. Most of the time it won't be. When we add 3 to negative 6, we'll get negative 3. So those are our two solutions for the top one. And you know, math is self-check, right? If you plug 9 back into the original blue, 9 minus 3 is 6 squared, 36. It works here as well. All right, the bottom one, we have to do something before we take the square root here in number 6, and that is because the squared is not by itself. There's this 2 out front. So we can divide by 2 first. That's what we have to do. And then we'll be left with something that looks similar to our top problem. The squared is by itself, so we can take the square root of both sides. So we're left with x plus 1, and then plus or minus. Now 20 has a factor that is a perfect square. So this can be broken down further. So we can write it as the square root of 4, the biggest perfect square that fits into 20, root 5. 4 times 5 is 20. And then we'll have x plus 1 equals plus or minus 2, because that is what the square root of 4 is, root 5. Now, how do we work on this? Well, we don't really need to make 2 arrows here, and that's just because this is not really nice. It's irrational. When your numbers are rational and nice, you can split them up and get 2 nice answers. In this case, all we're going to do is subtract 1 from both sides, and we'll write our final answer as negative 1. We'll put that minus 1 first, plus or minus 2 root 5.